21, you bet. Just dawns on me that I did not take attendance this morning. Oh, I did. Wonderful. Okay, let me take attendance really quick, and I will show you 21, no problem. What is 21? We have an 8 by 3 rectangle that we are cutting square bits out of, in which we will fold up to make a little open box. Okay, so that means we're going to end up with something that looks like this. And I don't expect you guys to be artists either, because I'm sure not. Let's see. We're going to have something box-like. And so the question is, how much do we cut out? So that ends up being the height. My box. Let me draw a different box. We could sit here all day until I'm satisfied with the box, but I'll just do my best. Let's see. Here's my 8 by 3 base. Here's the top. So I'll call this the height. It doesn't look great, but this will be, so we need to know what this dimension is and also what this dimension is. It turns out that this is 8 minus 2x and 3 minus 2x. Any questions about those? And so labeling my picture. And so the volume of a rectangular prism is just the product of its 3 dimensions. X times 8 minus 2x times 3 minus 2x. I could differentiate this as it sits, but that would be pretty problematic. It would be triple product rule. So I'm just going to go ahead and distribute before I do differentiate. This would be 8x minus 2x squared times 3 minus 2x, and I just need to FOIL. So I get 24x, that's first, outside, minus 16x squared, inside, minus 6x squared, and last is plus 4x cubed. I'm just going to go ahead and rearrange this. I get 4x cubed minus 22x squared plus 24x. So let's go ahead and differentiate. V prime is 12x squared minus 44x plus 24. Divide everything by 2. So I get 6x squared minus 22. No, can I divide everything by 4? Yeah, I can. Divide everything by 4, so I get 3x squared minus 11x plus 6. And so this becomes, right, and I want to set v prime equal to 0. 3x minus 2, x minus 3. Does this answer your question, Jalen, or do you want to see me keep going? So we get critical points, 2/3, and 3. Struggle. Yeah, so you always want to write a formula for whatever it says we're optimizing. So that, in that case, this is volume. And sometimes the shapes will be a little more specific, and I will give you those formulas, like if it's volume of a cylinder. I don't expect you to know that just right off the bat. So you just need to write a formula in one variable of whatever we're maximizing. So, and sometimes that will require substitution. Does anybody else have another question? These are going to be hard the first few times you do them, but they're going to turn out being easier and easier and easier. And personally, you probably won't agree with me, but I think they're fun. So let's take a look at 9. Get my book open, because I don't have the picture. So I'll walk through my entire thought process for how I get this set up. So we have some river. This is my river. It's beautiful. And we are building pink fence around the river. We have 3 sides. This is X, so that's also X. And furthermore, we are restricted to 1,400 meters of fencing. So 1,400 meters is my perimeter here, which would be X, which would be 2X plus whatever this is. I'm just going to put a placeholder there now. I'm just going to say L. I'm going to need L in terms of X. I'm just going to write 1,400, not 1,400 meters. I'm going to need L in terms of X so that I can optimize, right? So I can just solve this equation for L. So L equals 1,400 minus 2x. So now I have my 2 sides both in the same variable. We are maximizing the area. So my area function is x times 1,400 minus 2x. If this isn't, see earlier, if we had done it earlier before making the substitution, it would have been x times L. Well, that's not in one variable. That's why I had to make this substitution. And so now I have this. I'm going to simplify before I differentiate so I can save myself some trouble and grief. 1,400x minus 2x squared. Here's my area function. I'm going to go ahead and differentiate. A prime is 1,400 minus 4x. And I want to set that equal to 0. So I get 0 equals 1,400 minus 4x. So x is 350. And if x is 350, that means that L is 1,400 minus 2x. So L is 700 meters. And it also asks to find the maximum area. Well, we have the 2 dimensions now. The area is just the multiple of those guys. So A equals 350 times 700, which is the answer. 245,000. It's big. 245,000 square meters. Is that correct? Yeah, it is. 350 times 700. Does that answer your question, Helen? The reason, so you're asking why is this minus 2x? So this is a different type of problem from before. The reason that these dimensions are minus 2x is because we're cutting these 2 squares from each side. So the width is initially 8, but we're cutting out 2 squares of width x, so that's why the remaining width is 8 minus 2x. Now, the reason here is we have 1,400 meters of fence, and we've used 2x meters, so 1,400 meters will be built of 2x plus the rest. So if I've already used 2x meters, then the rest that I have will be 1,400 minus 2x. For instance, if x is 100, that means I used 200 meters, and that means I have 1,200 remaining. Does that answer your question? You there? Did she dissolve into the ether? Oh, so did that answer your question? Okay, wonderful. Cool. Let's get on with it, y'all. So let's do more optimization. Because what fun would it be without more? Let's see. Where'd my notes go? So, not only can we maximize, but we can minimize too. So, consider, so let's say there is a cylinder such that its volume is 1,000 centimeters cubed. And we want to find h and r, so this is height and radius. I'll do those in a different color. That's the same color. Find h and r such that the surface area is minimized. So say we needed some container to hold this volume, and say we want to save money on materials for the container, then in that case is when we would want to minimize the surface area. So we're going to find the smallest container in terms of surface area, the smallest cylindrical container that can hold 1,000 cubic centimeters of stuff. My mouth is moving faster. My brain is moving faster than my mouth. Okay, so I just need to take my time. So, and then here, surface area would absolutely be given to you. I would never expect you to know this, but the surface area of a cylinder is 2 pi r squared plus 2 pi r h. And so this 2 pi r squared, those are the two circles on the top and the bottom. And then 2 pi r h is actually this whole thing. Because if you were to cut the cylinder and just kind of roll it out, then this is h, and this is circumference of the circle, which is 2 pi r. So 2 pi r h is this face, and then the 2 pi r squared is these two faces. So that's the surface area of a cylinder. Again, anything that's not super easily apparent, I will give to you. So this is what we're trying to minimize. That's the goal here. Okay, it's the same story. We just need to put this in one variable and then differentiate, find our critical point, and minimize, right? So we need this in one variable. That means, well, pi is not a variable, neither is 2. I have r and h. I'm going to have to put one in terms of the other. Since this is r squared, I don't really want to mess with that. So I'm going to find instead h in terms of r. I'm going to go to my only other piece of information that currently exists, is that the volume is 1,000 cubic centimeters, and volume of a cylinder is pi r squared h. Well, I need h, and the volume is 1,000, by the way. Well, if I need h, then it's just 1000 divided by pi r squared. So I'm going to put this here. Geez. Let's see. I'm going to put this here. And let's see what we've got. So I have surface area equals 2 pi r squared plus 2 pi r h. And h, given that the volume is 1,000 cubic units, that means that h must be 1,000 divided by pi r squared. Before I differentiate or anything, I want to condense this just to make my life easier. So the pi's will actually cancel and the r's will cancel, and this will become a 1. So surface area is 2 pi r squared plus 2,000 divided by r. It would be 2,000 divided by r, but I'm going to express it as r to the negative 1 power. Now I can go ahead and differentiate. I get s prime equals 4 pi r minus 2,000 r to the negative 3 power, and I want to set that equal to 0. I'm going to move this to the right. I get 4 pi r equals 2,000 r to the negative 3. So if I cross these out, this becomes r to the negative 2. Well, actually, I'm going to erase this step. That step would have been fine, but I'm going to need to factor eventually. So instead, I'm going to divide by 4 first. So if I divide by 4, I'm left with pi r minus 500 r to the negative 3. And divide through by r. Wait. Isn't this r to the negative 1? What am I doing here? R to the negative 1. I'm going to factor out an r. So I get r pi minus 500 r to the negative 2 equals 0. Or in other words, this means that pi equals, so I'm just setting this equal to 0, pi equals 500 r to the negative 2. So if I multiply both sides by r squared times pi is 500, or r squared equals 500 divided by pi. Oh, this should be, I'm so sorry guys. This should be negative 2. So let me go back through this because I'm sure I've left some of you behind with my completely altered route. So here is our derivative, and I just divide by 4. So divide by 4, and then I'll even show you a better way to do this. So this is equivalent to pi r minus 500 over r squared equals 0. I'm going to move this to the right. Pi r equals 500 over r squared. I'm isolating for r, so I'm going to multiply to the left. Pi r cubed equals 500. Pi, actually r is the cube root of 500 over pi. So I think this line of thought should be a lot easier to follow. Go ahead and take a gander at that and make sure you're okay with this. And so the cube root let's see. Pull out my book real quick. Yeah, okay. And so if you take the cube root of this guy, you get approximately 5.419 centimeters. So we also need to know h. And so we need to go back to our volume equation. So 1,000 cubic centimeters is pi r squared h. Well, we have r squared. It's 5.419. 1000. So if I take 1000 and I divide it by pi times 5.419 squared, I will get h. So h is 1000 divided by pi times 5.419 squared, and we get 10.84. So ish. And so I'll circle R2. So let's just write off to the side. R is approximately 5.419 centimeters, and H is approximately 10.84 centimeters. And I can also check my answer if I need to. The way I can do that is check that this still stipulates a cylinder that is volume 1000. So that'd be pi r squared h. So if I want to put pi r squared h, that would be pi times 5.419 squared times h times 10.84. Is this 1000? It better be, or else my math was wrong, which it wasn't, but we can go ahead and check. And so you do get 1000 when you multiply these guys out. So I would always check your answer as well. Do you guys have any questions about this problem? I was a little in the clouds for a minute there, so I apologize about that. So notice we actually we only got one critical point here, so we didn't have to test. We just know for a fact that that's the answer. If there were multiple critical points, then you'd have to check. So let's take a look at another one. What do we have? Let me save this really quick. So we have a box with a square base. And we want to know what is the height so that the volume here is that 16,000? Yeah. The volume here is 16,000. Are we also saying cubic centimeters? That's fine. 16,000 cubic centimeters, and we want to find H so that the surface area is minimized. So our surface area here is 2x squared plus 4xh. The way I get this here is that x squared gives us the bottom, so the second x squared also gives us the top, and then each of these rectangular faces are xh, and there's 4 faces all around, so that's why we have 4 of them. Any questions about the surface area here? And if we want to minimize surface area, that means it all has to be in the same variable. So I'm going to find h in terms of x from this formula. So 16,000 equals, that's the volume, so that would be x squared times h, the 3 dimensions multiplied. So h equals 16,000 divided by x squared. So I'm going to substitute that in. So I get surface area equals 2x squared plus 4xh, where h is 16,000 divided by x squared. And so I'll actually get some cancellation here as well. This is common. These x's will cancel, and this exponent will become a 1. So I get 2x squared plus, is that 72, 96, wait, that's not right. Okay, I see why. This is 72,000 divide by x, but I'm actually going to write it as 72,000 x to the negative 1. So that's our surface area in terms of x. I'm going to go ahead and differentiate. So I get 4x minus 7200x to the negative 2. I want to set this equal to 0. So I get 4x equals 7200 over x squared, just moving this to the right, or x cubed equals 7200 divided by 4. So x cubed is 1800. X cubed equals 1800. Or x, so what is 1800 to the 1/3 power? We get 12.164 centimeters. So if x is 12.164 centimeters, we need to find h. So our volume is 16,000, and that is x squared h. This is from before, right? So that is 12.164 squared times h. So if I want to find h, I want 16,000 divided by 12.164 squared. And I get 108.128 centimeters. So we can check, is x squared h, so is this squared times 108 still 16,000 like it needs to be? And the answer is yes, so this is good. And this was the initial question. It was asking, what is h? Do you guys have any questions here? So I want to show another problem. So let's say we have a cylinder and for some reason the top needs to be made of aluminum. The top and the bottom both aluminum, and the side is tin for some reason, right? So, and then aluminum is going to be $2 per square centimeter. And then tin is going to be $1 per square centimeter. So knowing these two facts, we want to, well, first of all, we need this to be 1,000 centimeters cubed in volume. And we want to minimize the cost. So we need a cost function. Well, the cost is going to be $2 per square feet of aluminum, square centimeter of aluminum, plus $1 per square centimeter of tin. Okay, we can get that, right? The square centimeters of aluminum are coming from the top and the bottom. It's those circles. So this will be $2 per square centimeters on the circles, and the area of these circles are pi r squared. And there's two of them. That's the area of both circles, and then I'm multiplying it by $2. Plus, the area of this guy, of this face, will be circumference times height, or 2 pi r h. And so this will be $1 per 2 pi r h square units. Do you have any questions about the cost function? So we want to minimize this. Let's go ahead and simplify a little bit. So I get 4 pi r squared plus 2 pi r h. Well, I'm going to want h in terms of r. So let's go back up to the volume. So volume is going to be 1,000 cubic centimeters, and that is pi r squared times h. So if I want h in terms of r, I just want to solve this formula for h. So 1,000 divided by pi r squared is h. So I'm going to put that in here. So here I have cost is 4 pi r squared plus 2 pi r h, where h is 1,000 divided by pi r squared. So these pi's will cancel, these r's will cancel, this becomes a 1. And so I get 4 pi r squared plus 2,000 divided by pi r. I'm going to write r to the negative 1. Let's go ahead and differentiate this. So cost prime. So I get 8 pi r minus 2,000 piths r to the negative 2. I want to set this equal to 0, so I'm going to move this guy to the right. 8 pi r equals 2,000 divided by pi r to the negative 2. I'm going to multiply both sides by r squared, so I get 8 pi r cubed equals 2,000 divided by pi. These pi's cancel, don't they? And that's what MK is asking. They do, they do. So I just want to divide by 8 pi and then cube it. Cube root. So r is the cube root of 2,000 divided by 8 pi. And so we get 4.301 centimeters. And when you put stuff like this in your calculator, you need to be very careful with parentheses, otherwise it'll spit something out that is totally wrong. And so let's go ahead and find h. So going back to volume is 1,000 units cubed, and that's pi r squared h, or that's pi times 4.301 squared h. So h is 1,000 divided by pi times 4.301 squared. So if I do this, 1,000 divided by pi times 4.301 squared, I get h is 17.207. Now, these are the dimensions necessary, but the problem also might ask, what is the final cost of this cylinder? So let's talk about that. We can go back up to our cost function. We actually have multiple cost functions. There's this one with pi r squared and pi r h, but remember we simplified it all the way down to this just in terms of r. Wait, that's after differentiating. No, it's not. Yeah, so that's before differentiating. That's our simplest cost function, but we can use any of these. But I'm going to use that one. 4 pi r squared plus 2,000 r to the negative 1. And this is units, dollars. So I get 4 pi r squared. 4 times pi times 4.301 squared plus 2000 divided by r. So 2000 divided by 4.301. So I get $697.468. Of course, these are made up numbers. It doesn't actually cost $700 to manufacture a small cylinder, right? Any questions about this? So with most of these, you're just going to have one critical point, and you don't even need to bother testing the first derivative. If you just get one answer, that's going to be the answer. If you get multiple answers, which you won't, but when you get multiple answers is when you need to put them on the number line and test your signs and whatnot. So this would be a maximum, and this would be a minimum under those circumstances. Do you have a question, MK? Did you figure it out? Cool, wonderful. Does anybody have a question? So it's crucial here mostly just to take your time, be very careful about everything that's happening. You want to, I can write some tips here. So let's see, do I have space anywhere? First of all, you want to write a function in one variable regarding whatever you want to maximize or minimize. Possibly send the notes. Yeah, I can send the notes. And in the future, please let me know if I'm going a little too fast. I think I get excited, especially about calculus. So you want to write said function, differentiate, and in order to write this function, you will sometimes have to refer back to some information that the problem has given. So like we made those substitutions earlier, right? The problem will say it'll have some kind of constraint. Like you have only so much fencing, so much area, so much volume, right? Something will be constrained in order to let you make a substitution like we did earlier. Remember, we had cost in terms of R and H, but knowing that the volume has to be 1,000 units, then I can put H in terms of R. So you differentiate, and then this will find your critical points. And if it's only one critical point, you're done. If it's multiple critical points, you need to test. And then it may ask you to actually, the area and volume formulas. Yeah, I can give you the area and volume formulas. So let's see. Do I have any space? I think we just have rectangular prisms here and cylinders. So a cylinder, the volume is pi r squared h, and the surface area is 2 pi r squared h plus 2 pi r h. And a rectangular prism, the volume is length, width, height, and the surface area is 2 length width plus 2 length height plus 2 height width. Right, it's just the product of those faces, those 6 faces. No. You don't have to memorize any volume or surface area formulas. Absolutely not. Good question. Right, and then I mean, you're going to be doing this stuff on the homework. If you forget the volume or surface area, literally just Google it. That's fine. I don't care. So with that being said, the homework is these same pages, number 19, 20, 26, and 30. These will be a little harder than last time, so please let me know if you need help. These just take practice. So we got 4 problems for homework. The pages should be still posted above. Wait, they're totally not. So there are pages posted above. They're just so zoomed in that it's not what you need. So we need 19, 20, 26, and 30. I'll send those pictures. And please, if you could honestly get started on it today and see if you need any help so I can help you out, because I know this is going to be a pretty difficult homework for you guys. I'll dictate it aloud here in a moment, and I'll also draw a picture. I need to rotate these pictures. I'm taking pictures of the book, so. Cool, excellent. Yeah, let me send these pictures. I accidentally took a double picture, but that's fine. Apparently it never flipped. So you guys know how to flip an image, but if you wait just a moment, I'll flip it for you. But to answer your question, Jalen, this is 2LW plus 2LH plus 2HW, and I'll also draw you a picture here. So if you have, and so we're done, guys. So have a great day. So if we have some prism, and we have height, length, and width. See, 2 faces will be LW. Two faces will be HL. So these are the LW faces, these two, like the top and the bottom. And then 2 faces will be LH. They're these two. And then 2 faces will be HW, and they're these two. And a rectangular prism has 6 faces. Are you able to conceptualize that? Does that make sense? Awesome, wonderful, cool. Have a great day, guys.